If you could turn off one force in the universe, just for a moment, everything you know would fall apart. Literally. Before we begin, if you want to explore more mind-blowing truths about space, physics, and the universe, make sure to subscribe, follow, and stay with us.
Because what you're about to learn changes the way you see everything. Now, let's talk about something you experience every second of your life, but almost never think about. Gravity. Right now, as you're listening to this, gravity is holding you in place.
It's keeping your feet on the ground. It's keeping the air around you from drifting off into space. It's holding oceans to the earth. And it's quietly controlling the motion of planets, stars, and entire galaxies. But what actually is it?
At first, gravity seems simple. You drop something, and it falls. But that simple observation hides one of the deepest mysteries in all of science. Because gravity is not just about things falling down. In fact, there is no down in space. So why do things fall at all? To answer that, we need to go back hundreds of years to a moment that changed science forever. A man named Isaac Newton was sitting under a tree when he saw an apple fall.
Now, whether or not it actually hit his head doesn't really matter. What matters is the question he asked. Why? Why did the apple fall straight down? Why didn't it drift sideways or float upward?
Newton realized something revolutionary. The same force pulling the apple to the ground might also be pulling the moon toward the earth. And just like that, gravity became something much bigger. Newton proposed that every object in the universe pulls on every other object, not just big things, everything. You are pulling on the earth is pulling on you, and even two tiny objects, like grains of sand, are pulling on each other.
This idea became known as the law of universal gravitation, and it can be described like this. This equation tells us that the force of gravity depends on two things: mass and distance.
The more massive something is, the stronger its gravity. And the farther apart two objects are, the weaker the force becomes. That's why Earth pulls you down strongly, but a distant star, even though it's massive, barely affects you. Newton's theory worked incredibly well. It explained why planets orbit the sun, why the moon orbits Earth, why objects fall. It was so accurate that for over 200 years, it seemed like we had fully understood gravity. But then, something didn't quite add up. There were tiny errors, small inconsistencies in the motion of planets. Nothing huge, but enough to suggest that something deeper was going on. And that's when another mind
stepped in.
Albert Einstein. Einstein looked at gravity in a completely different way. He asked a strange question. What if gravity isn't actually a force at all? What if, instead, it's a property of space itself? To understand this, imagine space as a stretched-out fabric, flat, smooth, and endless. Now place a heavy ball in the middle of that fabric. It sinks. It curves the surface around it. If you roll a smaller ball nearby, it won't move in a straight line anymore.
It will curve toward the heavier ball, not because something is pulling it, but because the surface itself is curved. This is the essence of Einstein's theory of gravity. Mass doesn't just exist in space, it bends space. And objects move along those curves. So when Earth orbits the Sun, it's not being pulled in the traditional sense. It's following a curved path through warped space. This idea is called spacetime curvature, and it completely changed how we understand the universe. It also explained things Newton couldn't. For example, light. According to Newton, gravity affects objects with mass, but light has no mass, so it shouldn't be affected, right? But Einstein showed that light follows the curvature of space. So when light passes near something massive, like a star, it bends. This effect has actually been observed many times. It's called gravitational lensing, and it allows us to see distant galaxies that would otherwise be hidden. Gravity doesn't just shape motion, it shapes the structure of the entire universe. Without gravity, nothing would exist the way it does. Stars wouldn't form, because gravity is what pulls gas together until it becomes dense enough to ignite nuclear fusion. Galaxies wouldn't exist, because gravity is what holds billions of stars together in vast cosmic structures. Planets wouldn't form, because gravity pulls dust and rock together over millions of years. And you wouldn't exist, because every part of your body is held together by forces that rely indirectly on gravity's influence in the universe. But gravity also has some truly extreme effects. When something becomes incredibly massive and dense, it can warp space so much that nothing can escape, not even light. These objects are called black holes. Near a black hole, gravity becomes so intense that time itself slows down. Clocks tick slower, distances stretch, reality behaves differently. And yet, black holes are just one example of gravity pushed to its limits. Even here on Earth, gravity isn't the same everywhere. At the top of a mountain, gravity is slightly weaker than at sea level. At the equator, it's slightly weaker than at the poles. These differences are tiny, but measurable. Astronauts in orbit experience something even stranger. They appear to float, as if there's no gravity at all. But that's not true. Gravity is still pulling on them almost as strongly as it does on the surface. They feel weightless because they are in free fall, constantly falling toward Earth, but moving forward fast enough to keep missing it.
That continuous fall is what we call orbit. And orbit is one of the most beautiful consequences of gravity. It's a perfect balance between motion and attraction. Move too slow and you fall to the ground. Move too fast and you escape into space. But get it just right and you circle forever.
Gravity also connects everything in the universe. Right now, you are being pulled not just by Earth, but by the moon, by the sun, by every planet, every star, every galaxy. The effects are incredibly small, but they are real. You are part of a web of attraction that stretches across the entire cosmos. And yet, for all we know about gravity, there's still something missing. We still don't fully understand how it works at the deepest level. In modern physics, there are 4 fundamental forces: electromagnetism, the strong nuclear force, the weak nuclear force, and gravity. But gravity behaves differently from the others. Scientists have been trying for decades to unify gravity with quantum mechanics, the physics of the very small. And so far, we haven't fully succeeded. That means gravity is still, in some ways, a mystery. We can describe it. We can predict it. We can use it to send spacecraft across the solar system. But we don't yet have a complete picture of what it truly is. And that makes it one of the most fascinating forces in existence. So the next time you drop something, or feel your feet on the ground, or look up at the moon, remember this: gravity is not just pulling things down, it's shaping reality, it's bending space, it's holding together the universe itself. It is the invisible force that connects everything, including you. If you found this as fascinating as I do, make sure to subscribe, like, and follow, because in the next video, we're going to explore something even more mysterious.
If gravity pulls things together, then what is pushing the universe apart? What is dark energy? Stay curious, and I'll see you in the next one.